Number one. So what is focal length? So we talked about focal point. So if we have a lens has some focal point, and so when the light travels towards it, that light gets refracted or reflected. It's true for mirrors too. It gets refracted through that focal point. The focal length is how far away that is from the lens. So focal length is just your distance away from the lens, how far away it is. That's all it is. Just how far away are you from the lens. For the focal point, okay? So that place where the light gets focused, that's from far away. How far away is that from the lens or the mirror? But we're going to be sticking with lenses for solving these problems. All right. Let's talk about the two equations here, and then I'll define all the things for them. So the first equation is 1 over f equals 1 over do plus 1 over di. And then the magnification equation is m equals negative di over do equals hi over HO. I'll let you get those, and then I'll define each of the terms for you. Yeah, 1 over. No, you're fine. Okay, so all of those are set up there. Okay. So it's 1 over f equals 1 over do plus 1 over di. The other one is m equals negative di over do equals hi over ho. So none of these are that hard to solve, but they are kind of funky, and it takes a little bit of practice to kind of see them and understand what's going on with them. So this one is tricky because it's 1 over everything. That's not something you're used to doing. And this one's kind of tricky because it's got double equal signs, which is also not something you're used to. So I'll do an example and show you how they all work. But let's define everything first. So f, we already talked about, is focal length. Do is distance of the object. From the lens. So how far away is the actual thing from the lens? Okay. Di is distance of the image from the lens. Okay, so when it creates an image, how far away is that image? So when I was showing you these lenses the other day, okay, and it was making the objects, okay, like how far away is the image that I see from the lens? Like how far away actually is it? There we go. Okay. All right, hi. Let's do HO first. Height of the object. HI, height of the image. And M is magnification. Okay, I'll show you all these here in just a little bit. I'll show you how to solve them all. Again, if you're a little confused, how would I go about solving this? That's all right for now. I'll show you how to do it in just a second. And once you see that, I think they'll start making sense for you. Okay, So let's talk about magnification because there's some things you should know about it. So first of all, magnification is made up of two things, a sign and a number. So it'll either be positive or it'll be negative, and it'll have some number value for it. Okay? So if you have a positive magnification, okay, so positive magnification, that means it is right side up. And as you guys saw yesterday, images that are right side up are virtual. So when you had a right side up image in the mirrors yesterday, those were virtual images. It looked like you were inside the mirror. Okay, so if it's negative, it's upside down. And it was real. Those were the ones where, again, every single time you saw a real image, it was flipped upside down. And those were the ones that were kind of funky and trippy when your eyes were trying to look at them. Okay. Last thing I want to look at here is the number that goes with magnification. So if you get a magnification that's greater than 1, then the image is larger than the object. And if you get magnifications that's less than 1, then the image is smaller than the object. Okay, so if the image is larger than the object, it's positive, or it's above 1, and if it's smaller than the object, it's below 1. So a great example of this would be a negative 1/2. Negative 1/2 would mean that the object is, or the image is half the size of the object and it's upside down. So it would be a real image, be upside down, and it would be smaller than what the actual thing is. Okay, any questions on that one? Okay. Go ahead and go to the back.